parenthetics would be like, what were the givers again?
Well, for the block class, but you probably haven't even done the block homework yet. You're going to need get height and get width and get depth, and set height and set width and set depth.
Like we did today.
Yep, exactly. All right, so using files. Why would you want to use files? Because you don't want to have to recreate the data every time. You know, if you're doing a report on you know, the income levels of every person in Midwest City, you don't want to have to type in, you know, the 20,000 members of Midwest City or however, whatever the population is every time you run the report. Instead, you want to type them in once, and then you want to be able to run reports on it over and over and over. So really, you'd save them to a database, right? But or you type in, you know, your term paper and you want to print it out. Well, you don't just type it in, print it out, and then close the program and lose it. Instead, you type it in and you save it. So this is what this means. Allows data to be retained between program runs. So your general step will be open the file, use the file, read from it, write to it or both, and then close the file. I did start the recorder, didn't I? Now. And every time you work with a file, you generally want to close it as soon as possible. And what do I mean by that? If we have something that's going to create a file and write 5 lines of data out to it, don't just leave that file open, because the operating system's got a lock on it at that point. And if you try to copy the files out of that directory somewhere else, it'll probably give you an error message. You know, or if somebody else needs to open the file and your program's still got it open, then they're not going to be able to open it. So generally you want to close the file as soon as you can. Now, for what file access we're going to be doing in this class, it's going to look significantly different than in your Java class, because we're going to use the IO stream stuff. Except instead of doing CIN, arrow variable, we're going to do file, arrow variable, right? Or if you want to save something out to the file, instead of doing cout, arrow variable, you're going to do file out, you know, arrow, or whatever you call your variable. So modifying your programs to use files, to do access to them, is pretty easy. You're just going to have to create what's known as a file stream, either an input file stream or an output file stream, and then replace your CIN and your couts with the appropriate variable names. So you have to include fstream. And then you use ifstream for input. You use ofstream for output. And if it's got to do both, you just use plain fstream. We're not going to do that one. We're going to do ifstreams and ofstreams. And so to define your file stream objects, you just give the name of the stream. And then you give it you give the class, and then you give the variable name. And if you've done Java programming, you're used to having to do this, equals new ifstream, like that. Nope, not going to do that. This creates the object all on its own lonesome. So at this point, we have 2 objects. We have an in-file object and an out-file object. Now, by convention, file objects are typically called handles. We have a handle to the file. So to open a file, once you create the file variable, you call .open and you give it a file name. The file name can include a path, like if you want to open up something that's on the the C temp drive. Now there's a reason that I put 2 slashes rather than 1. That's because if it was just /t, then that would get turned into a tab, right? That would be dumb. So instead you use double slashes. Now there's a way around that, but when you're specifying a path inside your code, that is one way to do it. Another way is to make it look like Unix directories. Unix uses the other symbol like that, and Macs use periods, and they don't have C drives. But even on the Mac, I think nowadays they use the slashes. But the operating system should be able to handle both the forward slashes and the backslashes. So it's just up to you whether you want to do that. If you're going to use the backslashes, you better use pairs of them. So the file name may include a path info. The output file will be created if necessary, and the existing file will be erased if you're doing an output file. If you're doing an input file and it doesn't exist, instead it's not going to work, right? Kind of like if you're in Word, or Excel, and you try to open a file and you give it a file name that doesn't exist, what's it going to do? Not going to do anything. It's going to tell you it doesn't exist. And then if you do a save as, if the file exists, it overwrites it. If the file doesn't exist, it creates it. Same way. So you can test to see if the file opens successfully with this syntax, which looks weird to me, but that's because I don't program C++ 8 hours a day. You open the file like that, and then you do if not in file, then you treat it as an error. Or you can do this, if in file dot fail. That's my preferred way of doing it. To me, that makes more sense, right? That looks clearer to me. To a pro who does it 8 hours a day or 16 hours a day or whatever, then they probably like the other syntax because it saves 6 characters of typing, right? So you check to see if your file was opened successfully or not. If it's not, you tell them that it failed. You may give them a second chance at it, right? Just like Word, if you try to open a file and it doesn't exist, you get another chance to pick the file that you're going to open. So we could put this into a loop and exit the loop once the condition is not false. So you use the output file object and arrow to send data to a file, just like that. Looks real familiar, right? CIN was a console input stream, but outfile here is an OF stream, output file stream, but they're both streams. So the stream insertion operators work. Arrow that way and arrow that way. You want to write to a file, you send the arrows that way, just like you were doing cout. You want to read from the file, you use the arrows going the other way. So the stream extraction operator returns true when a value is successfully read, false otherwise. And that looks kind of weird. What do I mean by that? Say you've opened your file. F is equal to file.open. No, you just do that, sorry. File.open and you give it a name, right? File.txt. And then if not, file.fail, we're ready to do something. Now we're going to read from it, right? So file, arrow into X. Now how do we know if that worked or not? This looks goofy, but bool OK is equal to file arrow X. And then if not OK, then that failed. Read failed. You would print out an error message or do whatever you needed to do. Now that looks a little bit bizarre. And honestly, once the file is open, I'm probably just going to write to it and assume that the writes worked. And then later on, I could use what's known as exception handling to handle the case where the file fails, where the write fails to work, rather than checking each and every arrow. Now, when you're reading from it, it's useful to do this, while input file name, arrow number. That's like writing a for loop, and every time it goes, it's going to be reading from the input file another number. So what we're going to do after we fire up Visual Studio is we're going to write a function that writes out some numbers to a file, and then we're going to write another function that reads in numbers from a file. And we're going to use that functionality there to read the numbers in from the file. Display them, add them, do something with them. And then when you're ready to close, you call .close. And since they are methods, you use the parentheses. So you don't wait for the operating system to close the files that programs in. Yes, when your program is terminated, or when it finally returns, the operating system does close all the files, but you don't want to wait for that. There may be a limit on the number of open files, depending upon which operating system you're running in. There's always a limit. It could be a huge limit. Maybe buffered output data waiting to send to the file. The operating system could be doing some kind of buffering so that data is not flushed to the file until you close it. Back in the old days, like Windows 3.1, you had a limited number of what were known as resource handles. and every file you opened was a resource handle, and every window you had open was a resource handle. And so the more windows you had open, the fewer files you could have open, and vice versa. So you were supposed to close your files as soon as you were done with them. Letting the user specify a file name. You want to let the user type in the file name. In C++11, you can pass a string object as an argument to a file opens member. So when we open the file, where do we do that? Like this. We can pass in what's called a C string. This is a C string. It's just a quote, you know. It's a literal. But you could also pass in a string variable, like file name. But in versions of C that came out before the 2011 standard, they did not accept a string into that function. So you had to pull the C string out of it by doing that. I think it's either that or the whole word like that. We'll find out when I go back to that other slide. Doesn't say, but that's true. Now, I've had one student who came in here with their laptop and they'd installed a non-Microsoft C or non-Apple C or a non-recent version of C, and they ran into that. And so that's how we had to fix it, is we had to call that function that converted that string into what's known as a C string, which is just a null terminated array of characters. There's their examples, but our examples are going to be a lot better. So prior to C11, the open member requires that you pass the name of the file as a null terminated string, which is known as a C string. String literals are stored in memory as null terminated C strings, but string objects are not. But string objects have that function that will return a null terminated string. There it is, C_str. You only have to do that if you're using an earlier version of C++ than we are. So breaking and continuing a loop, and I think I've already been using break and continuing here. Is that true? Feel free to shake your head no.
Like breaks?
Right.
We've used breaks, but...
We've used break, but maybe not continue?
Yeah.
All right, that sounds right. Okay, but before I do that, let's play with the file functions. For some reason I'm paranoid about that. Okay, there we go. If you're going to play along, do the usual. Whatever we're on. Yeah. We're on M. M as in money. Okay. So, lecture M. But it's not a C# application, excuse me. Empty project. Make. Grab the boilerplate. But we're going to add a different include, or two different includes, or three different includes. We're going to include fstream, file stream. So I'm going to have to tack that on to the other includes that are coming in with my boilerplate. So add a new item, lecture m.cpp, paste. Alrighty. So what am I going to do? I think I'll just make a little menu that says, do you wish to read, write to the file, or read from the file? So int choice is equal to 0. While choice is not equal to 3, which is going to be quit. Then cout, arrow, arrow, 1 equals write to file, 2 equals read from file, 3 equals quit. Not quiet, quit, backslash it.
example of a C string?
Absolutely. Here's what a C string looks like. Char name 80 is equal to Jeff. What this does is it allocates room for 80 characters in a row, and it fills the first four spaces in it with JEFF, and then there's an invisible fifth one which has got a 0. So if we looked out in memory, we'd see the ASCII values for JEFF followed by a 0. And what is that 0 used for? So that functions that print out that string know where to stop. And you probably see a problem. What if I did this and I only set 3 characters for it? Well, this is too long to fit in there. And sure, this compiler is telling me that that's the case, but there could be times when you're copying data into that string and it will not fit. So strings are very primitive. C strings are very primitive, and that's why there's a string class that's supposed to supersede them, that grow and shrink, and you don't have to declare, a maximum size for the string right when you create it, and it's got all those methods. So that's a C string.
So you don't actually type out like C object dot C underscore str?
If you don't include the string class, then when you type the word string, I believe it is a C string. But I'm not sure. I always use the string class if I'm using C++.
I was just curious because I hadn't seen that example.
Yeah. Yeah, C is a different beast. It's a lot more primitive. Dealing with arrays of characters in order to store string data is primitive. It's almost assembler level programming. Alrighty, so, and then I'm going to have some if statements, right? Wait, I haven't read into my choice variable yet. CIN into choice, and if CIN is equal to 1, then we're going to call write file, which we haven't written yet, but write file. Else ifs. Wait, and why did I put CIN? What should that actually be?
Choice.
It should be choice. Yeah, so I need to replace that CIN with choice. Same here. Else if choice is equal to 2, then call read file, which I also haven't written yet. Else if choice is equal to 3, then print OK, goodbye. C out, arrow, goodbye, \n. And then a final terminating else C out, invalid choice.
You're a lot faster at typing than I am.
Yeah, so I'm going to sit here and pause and ruminate for a moment.
I don't
I'm a
even
fast
have
typer.
what's above that, so.
And I'm going to do some things to make the code all fit on the same screen. I mean, more of it to fit on the same screen. I'm going to remove the braces. They're not necessary, right?
You just can't get used to clicking the semicolon.
Yeah. Then I'm going to scroll up above main, and I'm going to add 2 functions. A void write file function and a void read file function. We're just doing this so that every single time we run it, we don't have to do both things, right? Sometimes we want to write the file, sometimes we want to read from the file. We don't want to always have to write the file before we read from the file. So if you're ahead of the game, go ahead and create a void write file function that all it does is see out the message writing file. And do the same thing for read file. And I'll do that. Okay, so I'm coming up above main, void write file, no arguments, so it doesn't take any parameters. And right now, all it's going to do is display a message, writing file, \n. That's enough to prove the point. And then void read file, parentheses in parentheses, cout, arrow, arrow, reading file. I'm trying to get the program in a working state as soon as possible, even if it's not going to do anything yet. Just like voting in Chicago, vote early, vote often. Instead, we're going to compile early, compile often.
Voting even though it doesn't do anything, huh? It's a little too on the nose.
Alright, so here's my menu. Write to file, read from file, or quit. I'm going to choose write, just make sure that works. I'm going to choose read, make sure that works, and I'm going to choose 4, which is an invalid choice, make sure that works, and I'm going to choose 3 to quit. Okay, I'm happy. Are we all ready to do the write file, or do we need me to pause a little bit longer? Wave your hand if I need to slow down. We all good? All right. So, what is write file going to do? We need to ask for a file name, and then we're going to open the file, and we're going to write some data out. Now, maybe we're not going to ask the user for this data. Maybe we're just going to generate a series of numbers or something, right? Maybe use a for to crank out some numbers. Since we're going to be doing file I/O, we need to add a new include. So # include brace fstring.
You already have that screen on top.
Oh, I already did it. All right. Well, that doesn't hurt it. Anyways, one thing I want to mention is that when we start adding our own header files, you're going to be modifying the syntax of the include to put quotes around the name. And what the quotes mean is look for that file in this directory rather than searching the include search path. Just wanted to mention that. All right. So let's ask for the file name. Let's create a file name variable too while we're at it. And heck, let's even create the output stream variable. So string file name, OF stream, which stands for output file stream, and I'm going to call it O file or F out, right? Just like C out. You can give these things any name you want. Now let's ask them for the file name. C out, arrow, arrow, quote, write to what file, question mark, space, end quote, semicolon, and read into file name. So CIN, arrow, arrow, file name. Something's looking weird there.
Your string.
You commented out the include string.
Oh, yeah, thank you. All right, now we have a file name. Let's open our file. fout.open, parentheses, passing in file name. And if we were on a pre-standard version of C, we would have to use .c underscore str parentheses in parentheses. You could do that just for compatibility's sake. I'm just going to remove it. Alrighty, now we're going to test to see if the file is successfully opened. If not fout, not evout, or my favorite way of doing it is if fout.fail, like that. Whichever one you like, not fout or if fout.fail. Let's print out an error message and return. Could not open file, end quote, followed by the file name, followed by ENDL. if that's the case, what are we going to do? Are we going to loop, making them give us a good file name, or are we just going to return? What I'm going to do in this case is I'm just going to do a great big else right here. Now, I could put a return here legitimately. You know, we ran into an error condition, bail out. That would be okay, but I'm going to go ahead and put this in an else. At this point, we have a file handle that we can play with. fout is a valid file because it didn't get .fail. It opened the file successfully. Now, I've made a mistake already. Later or earlier when I mentioned you were going to open a file. No, I'm sorry, that was Java. Never mind. Okay. So, let's save some data to that file. fout, arrow, arrow, you know, the number 1. And then fout, arrow, arrow, the number 2. And fout, arrow, arrow, the number 3. And then close the file, fout.close. And then, just for giggles, and this is only going to work on the Windows machines, and I apologize for the Mac users for that not working. After we call close, let's try to edit the file with Notepad. Why don't we not and say we did? Never mind. We'll go open it by hand. Never mind. I don't want to do something that leaves the Mac users out. All right, I'm going to run it and see if I can create a file. Write to a file. 1. Write to what file? Well, I'm going to call it lecture. No, that's too long. I'm just going to call it m.txt so I can find it later. All right. Now, I didn't even put a success message. I wish that I'd gone ahead and put in a cout, you know, write done, but I didn't. Now I'm going to choose quit, and I'm going to go and look for that file. Go and look wherever your CPP files are stored. So I'm going to bring up my Solution Explorer. I'm going to right-click on the solution name. I'm going to do Open Folder and File Explorer. I'm going to go down into Lecture M, and there's my text file, m.txt. And when you ran it, if you called it .txt, when you double-click it, it'll launch your text editor. And you Mac users, I have no idea where it creates that file. I don't know how to tell you how to go find it. Give it a distinctive file name and then do a search, you know, with your little magnifying glass and see if you can find it. And if you can't, you're just going to have to trust that it's there. The other thing you could do is you could give a path that went to a directory that you knew existed, right? Like your user directory or something, but meh, not going to try to help y'all with that. Okay, now I see something that I don't like. And what is that? When I wrote those numbers out, what did it write? It wrote 1, 2, 3, rather than 1 followed by a space or 2. What I would probably like would be either that, spaces between them, or with lines between them. And why is that? Because later on, when I write some code and I wanted to store those into variables, right? If it's formatted like that, 1, 2, 3, then A is going to equal 1, 2, 3, and there's not going to be any data for B or C. So I'm not real hip on what got created there. I need some kind of delimiter so that I can pull the pieces of data in individually rather than being all concatenated in one thing. And give another example of that. I'm going to add a couple of print statements here. Not print statements, fout statements. I'm going to fout my first name, right? Fout Jeff. And then I'm going to fout my last name, Thompson. Then I'm going to run it again, except I type cout just by habit. Make sure they're all fouts because that's our file handle. That's our OF stream variable. Run it. Okay, write to file, read from file, quit. I'm going to write to file. Write to what file? m.txt. Great. Quit. I'm gonna go back and check my directory. It ought to still be in that directory as it was, m.txt. All right, isn't that cool? No. So I need to either be putting spaces between them or I need to be putting them on their own lines for this to work in this fashion. So that's what I'm going to do is I'm just going to write out an ENDL after every piece of data I write. And while I'm at it, I'm going to add a statement that says file written, right? Cout. How about I output the file name? File name, arrow, arrow, quote, space, written, \n, end quote, semicolon. All right, m.text written makes me happier. I have some indication that it worked. All right, now everything is on its own line, so when I call fin, arrow, arrow, when I read from the file, they will come in as individual pieces of data rather than it's just one long string with everything smushed together. Okay, so now what am I going to do? I could modify this creating of the file program to have a little bit more interesting data than just a name followed by, 1, 2, and 3. Or why don't I just leave that alone and then go and modify my create a read program. This is working for everybody. I don't want to keep going. What happens if we do a build, rebuild all? Rebuild solution. Okay, I'm going to do some dumb stuff. Here. Where is our solution explorer? This file is not in
It's not in the
that
source.
directory. So why don't we, oh, by the way, that looks a little bit odd there. But anyways. The name, what are we going to call it? Close this one. Maybe we'll be good to go now. Okay.
So when I run mine, as written there, everything printed except for the file line, CF file name written.
Right, but that's because it is cout. That was for displaying on the screen. Fout is for saving in the file. Yeah, if you want to write that message out for the file, you can do that.
So I should have a file that
think so, and I've never been able to find out where Xcode saves it. So what you can do is you could hard code the path to like your desktop or to something like that if you don't think you need a convention.
Would that be in front of file name?
Yeah,
Okay.
yeah.
Where's the file saved again?
It's saved in the project directory in the same directory as your CPP file.
Yep, there it is.
And since it didn't have a .txt extension, it doesn't know how to open it, so just use TextPad or something.
Wait, where was I supposed to add,
When I was giving a file name, I typed in .txt.
Oh,
Yeah.
and then I'll automatically give it a file.
That's how Windows associates it with an app to handle it. We could do something awesome like check to see if it had .txt at the end, and if it didn't, we could append it. But anyways, okay, so we have something that will write the file out. Now we're going to write something called a read file. It's going to do the same thing, but we need an ifstream object. We need an ifstream object rather than an ofstream object. So ifstream, and I'm going to call this fin, like CIN is for console input, fin. If I was in a different mood, I'd call it in file, right? In file, or input file, you know, whatever. Just be called if I wanted to be a jerk. And let's make another file name variable, string file name. Same business, let's ask the user, read from what file, name, question mark, space, end quote, semicolon, and CIN arrow into file name. Now we're going to open the file the same way we did. fin dot open parentheses file name. But it's possible that failed. If it failed, it means that the file name does not exist. So again, if not fin, or if fin dot fail parentheses in parentheses, let's display an error message. Cout error quote, error could not open, space end quote, error file name, error end up. Alrighty. Else, we have a good file. It's got 5 pieces of data. We could just write a loop that will read everything from it. Let's do that first, and then we're going to yank the loop away and we're going to read in the individual pieces of data. Right, because they don't all mean the same thing. 2 of them are words, and then 3 of them are numbers. So just writing a loop that reads all 5 of them wouldn't make much sense, but for a first go, let's do it. Let's declare a string variable, string s, and then while, and this syntax looks crazy, and I've never seen anything like it except in this language. No, that's not quite true. Python has a variation of this. While fin greater than into s, cout arrow, quote, I just read, space, end quote, or maybe even a colon there. I just read colon, space, end quote, arrow, s. Now, I'm not sure if we need an ENDL there or not, so I'm going to put it there, and then maybe I'll delete it later. I think we need it, because CIN, or anyways, the string insertion reading from a file stream tokenizes it, right? which removes all the backslashes and stuff. So when we print it, we need to add the EMDL. All right, that'll do it. And then once that while loop is done, we're going to close. Let me modify the formatting of that so we can see it. So fn.close. And let's write a message saying that we're done. Cout, arrow, arrow, done reading from, space, end quote, arrow, arrow, file name, arrow, arrow, MDL. Now it could be that fout and cout as variable names were too close to each other, that they were confusingly similarly named. In which case you might make it, out file rather than fout. And if CIN and FIN, those names being too close together, make it confusing, then change FIN to something else. If you want to change a variable and have it change everywhere, highlight a variable, right-click on it, and do, oh, there's no refactor option. There is in C#. Never mind. Okay, anyways, this ought to be good to go. I'm going to run it and see. Okay, so I'm going to write to the file first, just in case I don't remember what it's called. Write to m.txt. Yay, it wrote to it. Now I want to read from it, so I'm going to choose to read from file, m.txt. And there it read each line of data. Jeff Thompson, 1, 2, 3. Okay, nifty slick. We have taken our data and we have made it, we have written it out to file. And there's a term that I'm looking for that's lurking in the back of my head that computer scientists use, like we've provided serialization for it or something like that. But anyways, we wrote a file and we read from it. That's pretty cool. Maybe we're going to get rid of that while loop though, and we're going to read in those 3 variables by hand. What do I mean by that? We're not going to just use a loop and print them out. Let's do this. I'm going to comment out all of this stuff. From here down to the closed brace. Because that worked good as demo code, but we didn't get to do anything with that name. So how about declaring some strings, like fname, comma, lname, first name and last name, and then 3 numbers, int x, y, and z. All right, fin, arrow, arrow, fname, fin, arrow, arrow, lname, fin, arrow, arrow, x, fin, arrow, arrow, y, you get the idea, fin, arrow, arrow, z. The question becomes, how do you handle it if that read fails? I guess we'll play with that. We could modify the file and then try to read from it and see what happens. But for now, we're just going to expect that it works. And let's print out that stuff. Cout, arrow, arrow first, or name equals, right, end quote, arrow, arrow, fname, arrow, arrow, space, arrow, arrow, lname, arrow, arrow, endl. And then just write x and y and z out. Cout, arrow, arrow, quote, x equals, space, end quote, arrow, arrow, x, arrow, arrow, endl. And I'm just going to copy that and do the same thing for y and z. So the file's already created, so I'm not going to create it again. And I read from it, my name is Jeff Thompson, and X, Y, and Z are 111. Is that what I expected? I don't think it is. I think that the text file was supposed to have something different in it. I thought I wrote out 1, 2, and 3 or something. Yeah. So where to get 111 from? Oh, let me guess. What did I do wrong?
You printed out X each time.
Yeah, I printed out X each time. Brilliant. Alrighty, there we go. I'm gonna like it a lot better now. Write to file, read from file. Okay, read from the file, read from m.txt. Jeff Thompson 123. Okay, I'm gonna go and edit that file and change my name. The Mac users who can't find that file aren't going to be able to do that. So instead of being Jeff Thompson, my name is going to be Bob Roberts. Now I'm going to run it again. Read from file, m.txt, and my name is Bob Roberts. Okay, so that works. What if I have a problem in the file? What if I only have 2 numbers waiting to be read rather than 3? I'm kind of curious. I actually don't have a prediction for the answer to that question. So I'm going to go and edit that file again. And I'm going to delete one of the numbers. How about I just delete the first number? Alrighty. Neat. Not really, huh? So, in this case, we could validate whether we read from it or not using that little bit of code that I showed you. Then, now here's what I'm going to do, and it's not what the book is going to show you, is that I want to check the result of each one of these reads here. So I'm going to create a Boolean variable called bool be okay, or maybe just okay, and we're going to default to being true. And so here's what I'm going to say. Okay is equal to okay or that. And I'm going to put that in front of each line. Now that looks obnoxious, and I've never demonstrated that to another class before, but I've never actually tried to take this in this particular direction. And then by the time we're done, we can check the value of okay. If okay equals false, or if exclamation point okay, we want to be pro about it, then we're going to write out an error message. Cout. File format is not correct. Don't you love that kind of error message? You have no idea how to fix it. So what is this business doing? I could have made it bool be okay 1 and bool be okay 2 and bool be okay 3. That would have been easier to understand when you looked at it. I'm going to put some parentheses here to try to make it a little bit clearer what it's doing. So okay is true, right? And then we're going to use or to put the result of this. And if this is true, oh, I better make that and. Both sides have to be true. We want the reads to succeed. So change all those ors to ands. And I wonder if there's a compound operator for and equals. Can I do and equal like that? Is that legit? No. Can I do and equal? I don't know if I trust that. Guess I could try it. And equal operator, C++. So yeah, we could use and equal. That might make it look a little bit clearer. It might make it look uglier. Maybe we don't want to add this error handling at all. Maybe it looks too nasty. Oh, what do you know? And it's still complaining. Alrighty, I'm going to undo all those. Alright. Alright, now I'm going to test it before I start lecturing too much about it. And whether or not you use the parentheses around it, it's going to work the same way. Let me make sure it works first before I start talking about it. Read from what file name, m.txt. It didn't catch the error. Alrighty then. Alright.
But it caught it when you had else.
Oh, it actually did catch it, and I just didn't notice it because I didn't have an else there. Yeah. 2 m.txt. File format is not correct. Okay, so I needed to put the rest of this inside of an else. Right. Else, quote, or else curly brace, and put all those C-outs there. Alright, now what I'm going to ask is whether this makes sense to you or not, what it's doing here. And if I give you an assignment, which I'm going to do based on this idea, I don't care if you put this error handling in it or not. But why am I doing this okay, ampersand, ampersand, and then this business? If nobody knows, that's okay. But does somebody know? If I start calling out people's names, what is this doing? Well, according to the text, that returns true or false. That operation right there. It returns true if the read was successful. It returns false if the read was not. Would it make more sense if we did it like this? Bool OK1 is equal to that. Bool OK2 is equal to that. I guess I better put these in parentheses to get that to work. Oh, all of a sudden it's not working at all, but it was working earlier.
Is it because you didn't have OK defined once you deleted the bool OK equals true?
No, because now I do have it defined.
No, but if you erase the bool OK equals true, then the OK gives you an error, right?
Right, but I'm getting one anyways. So for some reason this is working, and what I have there is not working. And that means that it's not that it's well, I'm going to blow it off. I'm not going to even mess with it. If your data format is not good, then your results are bad. Garbage in, garbage out. Because I don't want to sit here and talk for about 17 minutes trying to explain that syntax. It's worth understanding. We'll probably hit it again. Okay. So I'm going to undo all the changes I made. If you like it, you can leave that stuff in there. You don't have to undo everything just because I did. But in the code example, I'm going to leave it out. All right. So at this point, we could do something useful with this data, right? Whatever we needed, like int result is equal to x plus y plus z, and we could print it out, do something with the data. gonna create some homework from this idea, which I am. Here's what I wanted to do. I wanted to display a menu like this. 1, write a triangle file. 2, read a triangle file. 3, quit. If they choose 1, then we're going to ask, what is the base of the triangle? And they're going to type in 10. And then what is the height of the triangle? I'm going to type in 10. And then we're going to say, save to what file name? And I'm going to type in t.txt, and it's going to say, file saved. Then it's going to display this message again. 1, write a triangle. 2, read a triangle. 3, quit. So they're going to choose 2. What's it going to do then? Well, it's going to ask for the file name. Read from what file name? They're going to type in t.txt, and it's going to say triangle base equals 10, triangle height equals 10, triangle area is equal to 50. Then it's going to display the message in here again, and they're going to choose 3, and it's going to quit. Does that make sense? So, your write file function is going to ask for, where'd it go? Oh, it's going to ask for the base, and it's going to ask for the height, and then it's going to write those 2 values out to the file, and it's going to close. Then your read function is going to ask for the file name, it's going to read in those 2 values, and then it's going to display those 2 values as well as displaying the area. The formula for area, which I know we already know, we've already done another assignment like this, is 0.5 times base times height. Does that make sense, guys? Feeling good about that too? No. Well, let's do write file. Let's choose 1. Go ahead and choose 1. The file name, m.txt. Right. Okay, good. Now let's go and find that file. So right click on that. And then do open folder in File Explorer. And there's m.txt. So go ahead and double click on it and see what it looks like. Yep. Now notice that there's no spaces between these numbers. So go back to your code where you write your file. Probably at the very top. And put ENDL after the 1, 2, and 3 as well. Does that make sense? Vincent, you feel like that's a good assignment? You can do that? You good with it? Do we need to do another example of it on next Tuesday? That would be my question. And the answer, yes, is totally okay.
Just on this one that you did today, did you start by creating m.text?
I did not create m.text with a text editor. The software created it. Our program did when we used the OF stream.
And it just like, I don't, is that in the code? Like I was copying you and I don't know, like.
Yeah, a good question. Good question. And so, yeah, we better lecture about this again on Tuesday. That's totally okay. I was kind of planning on it anyways. But